Okay, I think I can keep myself from ranting here this morning. Thanks for joining me in my shop. I'm going to be going another step with this radio, at least one more step, and I think what's next in line is to test the tubes in the radio. So the radio's behavior sounds to me like circuits oscillating, something like that. Maybe something traveling on the ABC line or who knows what. But I think the next logical step is to clear out the possibility that there's a defective tube in the radio before I go any further. So, on that note, let me spin this around here, and we will start with the 12BE6. 12BE6. Yes, I honestly have been in here for, here I go, for 20 minutes, and every time I started that video, I started ranting. And here I go. I don't know if I'm going to be able to stop it, because I know some of you are American. In fact, a lot of my viewers are American. And, you know, Canada, America, wonderful friends. Do a lot of stuff together. Have agreements to treat each other like brothers. Don't we? Yeah, free trade agreement. Biggest one in the world. No other countries have such trusting agreements. Trusting agreements to the point where we're willing to rely on each other. So the US relies on Canada for 30% of its oil. And Canada relies on the US for, well, a heck of a lot of food in the winter. But apparently we can't rely on the United States anymore, because regardless of the agreements we have with them, they clearly do whatever the heck they want. I can't stop the rant. Including pirating. Yeah, if you're an American citizen, if you haven't really figured out yet what your country has been doing, or started doing, stealing stuff from other countries. Now, I don't know if it's absolutely true. There's 3 countries complaining that American agents hijacked deliveries of materials. I don't know how much of that is being talked about in the United States. It sure is being talked about in those 3 countries, France, Germany, and Canada. Hijacking stuff destined for those countries. Right on the tarmac. Now, is it true? I don't know. But for sure what's true is the American president has said, we're not going to share anything with Canada, even though we have this brother agreement. It's, you know what, I can't carry on. I can't do the work. I cannot do this stuff. I can't do it. Okay, let's see if I can keep my head above me. See, I don't have all the patience in the world, even though it might appear I do. I'm just another person like everybody. And, you know, let's just put it this way, man. When the chips are down, you find out who your friends are. That's for sure. And I know which countries are helping us right now. And I know which country is going to screw us. You know what? I'm not going to be able to do this. I am not going to be able to do this work today. For crying out loud. I am so upset. That should be 4, not 8. 8L. 51. So if you tuned in hopes that I'm going to calm you down, that's not going to happen. I'm not calming anybody down. Why should I? 40 more. See. Okay. Why should I? Does I sound a little different today? Well, it's the real me again. You always see the real me on my videos. This is the real me. Oh, for crying out loud, nothing. This should come up to 1350. I'm just going to have to... Tell me this isn't working. Come on. 12BE6, 8L. 51763. 51763. 3000. 3000. It's an unusual number. 3041. C. Full tube test. 1500. This tube isn't even heating up. I think it's my tube tester. So we're going to revert to another tube tester. And I'm going to go and calm down. Sure I am. I'm finding it a little hard to believe that that tube is bad. So we're going to test it with another tube tester. We're going to test it with this guy here. So, a number of videos ago that I did not post, I pulled this tube tester out when I was working on another 5-tube series radio, and I didn't post it because so many things went wrong. Once I got this tube tester out, I ended up with 3 tube testers, conflicting results, errors made all around. I totally lost my mind last time I tried using this. So, let's see if I can keep my head about me when all those around me are losing theirs and blaming it all on me. Okay, I've got the roll chart on my other computer screen so I can set this guy up. Let's go through it. So this is the on-off switch. It's off right now. 12.6 volts. That's where this is set. Good. C, G, 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 nothing. C, G, 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 and this one doesn't matter for this particular tube test. It can be set anywhere. Next one, 1, 2, 6, 5. Whoops, wait a minute. Already making an error. Looking at these roll chart strips, especially when they're not in a little window like this, but they're up on the computer screen, it's real easy for your eye to just go up and down a line and pick off settings for the wrong tube, which I do all the time when I'm doing this. So BG, so got my finger on it now. BGAG, finger on the computer screen. BGAG. 2, 2, 6, 5, 4. 2, 2, 6, 5, 4. 30. Just be sure what I'm seeing here. 3100. 31. 3 zeros. Bias voltage is set to 0. We'll have to take care of that when the time comes. Then we've got the GM. There's a number of tests for this tube. In this tube tester, there are 4 tests you can pull on this tube, plus a couple more, in fact. So what we're aiming for is to do the GM test. Okay, I think we're ready to go. I need the tube. 12BE6. We'll switch it on. Double check the filament voltage. Plug it in. Boy, that's a really tight socket. Holy smokes. Now, we're going to be able to read the filament current directly with this tester, which is an unusual thing. Most testers that the other 2 testers I have, or 3 or 4 I've gone through, have never been able to do that measurement. I'm going to put that on test. We're going to throw this on the 3 amp scale. Now we're going to throw it on the 0.3 amp scale. It's 150 milliamps flowing in this tube right now. And that sounds to me like the exactly correct, and not probably, every other tube in this radio must also work with the same current going through its filament. So that's good. Okay, 150 milliamps. Now we'll set the bias to 0. Okay, that's 0. We'll check the line voltage. Should be straight up. It's just a hair low. Not that that would make much difference. Back to the test position. Next thing we want to do is test for shorts in this radio, in this tube. So we're going to go through the short test. Here we go. It's all based on this light, and we expect shorts to show up. Shorts should show up on 3 and 4. Here we go. 10, 9, 9, 8, 7, 6, 5, 4, 3, 2, 1. So flashing light, you can see that on, yeah, you kind of see it on the camera. Doesn't mean anything. Back into the test position. We're test. We're in test. So now this is the real test button here. See what it says, test off and hold. So if we flip it to test, there's a spring load, and when you let go of it, it'll just go back to off. If you want to leave it on test, you can snap it on to hold, and it'll just sit there. So the expected measurement here in this test, 12BE6, is 900. So we check this by looking at the scale indicator here, which is the 20K, or 20 scale. 20 is this top one here. On the 20 scale, whoops, hold still there. On the 20 scale, we're looking for 900. So 900 is way down here. This is the thing about this tube tester. Some of these tests are just like right at the bottom here. Okay, let's try it. Oh boy, what do you make of that? Oh. It seems to me that this well, that's two testers now that have suggested this tube is a dog. Have I got this right? Test. This is the oscillator side, I think. What is this? This is not the oscillator side. So this is the 12BE6 amplifier side of this tube. 0 volts. Let me play with the bias a little bit and just see if that's not a major sensitivity. Nope, not at all. Well, I think we have to conclude the tube's a dud. I'll be putting another 12BE6 in here, and we'll repeat these tests and see what happens. This is a 12BE6 right here on my bench. Well, I'm going to do it right now. I mean, there's another whole setup here. We could do another test of the other part of the tube, but it's easier to pop that tube out, pop this one in, and see what the difference is. Pop. Have to go through the short test again. Here we go. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Back to the test position. Tube's heating up now. Let's check the bias voltage again here. Make sure it's down as low as we can get it. 0. Ready for a test. Oh my god. Well, this time it stays up. Oh, it's still going up a little bit. I hardly move that meter. Again, that's the thing about this tube tester, is a lot of these tests are just right at the bottom of the scale. Son of a gun. Okay, so it's supposed to come up to 900, and on you know, wow, that's 500. So, hey, I'm on the same journey I went on last time. I'm going to have another tube tester out here. I'm going to get another result from it and wonder. Well, let's leave that tube there. Turn off the unit. We're going to switch to the other test of the other part of the tube. BGGG. BGGG. 12650. 12650. 42,000. 42000. 2 volts this time. 4500. And it's on the same scale. So 4500 is way up in here. Well, that's a good high reading. Okay, I think I have this set. Flip it on. We'll go through the short test again, just to be sure. In this case, shorts appear on the same thing, 3 and 4. 3 and 4 are the heaters. Pretty sure of that. Okay, here we go. 4, 3, Okay, we'll let the tube heat up a little bit. I'll double check in the meantime. It should be 4500. This is the oscillator. Oh, 2-volt bias. Okay, we gotta set up a 2-volt bias. So we're on the 10 scale. Way down at the bottom here, 10 scale. 2 volts looks like this. There we are, 2 volts. Back to the test. I need a little drum roll or something at this point. 4500 above my thumb. Low. Well, you know, I just found this tube laying on my bench, and often there's tubes laying on my bench because I've rejected them and left them on my bench. So time to get a bunch of 12 BE6s in here and find one that shows good. I can't believe this is going like this. But wow, am I ever distracted? It's fantastic. Okay, I'm going to start mixing everything up. This is the original tube. I'll lay it back here on the radio. This is my first possible replacement. Doesn't look too good. Now in here are tubes I know at least basically pass a test. These tubes are not dead. So now in here, not necessarily are they all great. Eeny, miny, mo. BE6. Okay. Let's give them a go. Oh, jeepers creepers. There we go. I may end up going through all these. So the last time I was doing this tube testing, as I mentioned, I never did post a video from it because the whole thing became a total schmozzle, and I feel like I'm on my way down the same road here. So we need to test this guy for shorts. Three actually. Testing. Bias should be 2. Bias is 2. Test is ready. 4500. Holy smokes, absolutely nothing. Test. Current. There's no current. Okay, hold on a second now. This tube is here because I tested it successfully. When I plugged it in, I saw this dip. Oh, you son of a gun. So a couple things happened there. One is, I got socket problems here. 2, I had the meter set to 0.3 amps full scale. You saw it go all the way over and whack, because the inrush current is that high initially. You may have noticed too, the meter went up, it didn't go all the way over, it's stuck here. This meter stopped short for some mechanical reason inside it, I don't know why. But it's way up here in the high zone, so I don't worry too much about it. Okay, so how much is the current flow? So the current flow is a little over 150 milliamps. Check the line voltage. It's right on. So why that's a little high as compared to other tubes? Must be the filament resistance. Must be just a wee bit different. You know, I don't know about how rigid a voltage this thing supplies. If you set it to 12.6, is it 12.6 no matter what current flows in there? Probably not. There's going to be some variation in the supply. So, but it's a small amount. Who cares? 45. higher reading this time. Why is that? So it's not going to get to 4,500. Stopping at around 3,250. 4,500 is a reject point. It should be at least 4,500. This is the original. As I've mentioned before, doing this with multiple tubes and multiple testers is like the guy with more than one watch who never knows what time it is. And that's kind of the risk I'm taking here. Let's see now. This guy tested very, very poorly last time. What's up? What's up here? What's up? What's going on? What's going on? Could it be bad socket? Because I concluded this was a bad tube. Now it's testing great. What is wrong here? Okay, let me double check all the settings again. Because, you know, what I am really trying to do here is stay away from watching TV. So the longer this takes, the better off it is. 12BE6. So 12.6. B, G, 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 B, G, G, and G. Last setting means nothing. 12650, 12650, 4200, 42000. So those are all correct. 2 volts, 4500 oscillator. Well, now it's all the way up there. Now it's well above. Now the tube has gone from I don't think it's working to it's beautiful. It's wonderful. I've never seen anything like it. Man alive. That's why you need a tube tester. Just to confuse the living bejesus out of you. Okay, let's go back and test the other part of the tube then. BGAG. Better pull it out. B G A G 22654 22654 22654 3100 3100 Okay. I won't bother saying what I'm thinking. Bias is going to be closer to 0, 0. Here we go again. Oh my gosh, I bladed all the tubes down. Who's who? Okay. This is the hottest one. Is this the last one? Oh my god, I've mixed them up and lost track of which one was original. Of course, I had video on all this time, but you have to go back and look at it. Oh my god, what a dummy. Yep, I'm definitely going down that road of massive confusion. Okay, won't worry about the short test. Bias setting. 0. Test, 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 test. Well above. Okay, so it's testing good. Now I'm just really, really beside myself. So I think this is the original, but I don't know anymore. As long as I put a good tube back in the radio, that's what counts. Is the reject on this. So, you know, well, it's going to make it to 900, I think. Wait a minute. Didn't we just... Yeah, that's right. I just flipped this. Yeah. Boy, I tell you, I'm really close to losing it here. Really, really close. So that would test good. This guy's good. Good on both accounts. Oh my gosh. The one thing I've definitely learned in doing this is if you test a tube bad, don't believe it. Just don't believe it. Work really hard to convince yourself it's good. Good. All testing good. I mean, I'd like to have a bad tube. A bad tube would be a good thing. We have a whole bag of replacements there. Bad tube, fix up the radio. He's testing good too. 3 good tubes. That's what this really is. And I think this is the original. I don't know though. There we go. 1 tube tested. I better get rid of these. Next thing you know, I'll be messing that up. Okay, who's next on the confusion parade here? And it looks like a rectifier tube, what it looks like. It's the 35W4 rectifier tube. Well, I can't imagine that's a problem. Okay, I'm going to stop. Next time I come on, we'll have that set up and do the confusion. Yeah. Okay, I made the terrible mistake of looking at my television set. I won't say anymore. Okay, so we're ready to go here. 35 volts. There we go. Saw the light dim. We need this to be here to start, and the shorts should be found on 3, 4, and 5, I think it was, wasn't it? 3, 4, and 6. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Perfect. Okay, put it on test. When you put this on test, this control on test, it turns the heaters on in the tube. The short test is done with the heater switched off. Well, a lot of the shorts are to the heater. Bias should be 0. Good. Line check because this tube, no, this is not a heavily drawing tube. It's actually drawing, again, 150 milliamps. Yep, straight up scale. Okay, if one of these tubes in the series radio, if for some reason the filament is, I don't know, shorted out or something, and it draws a different current from this, then that would upset the radio tremendously. So this is a EM test. This is not a GM test. There's no GM in a rectifier tube. So this is just EM. EM is emissions. So this is more like an emissions tester. And so what we read is they're replacing good. There's no numbers. Here we go. She's good. See again, my needle's stuck. Whack, right there. Lucky it doesn't stay up there though. So good. I'm gonna get this out of here before it gets so hot I can't touch it. Okay, the next tube. Hey, that went pretty good. That went pretty good. Now what could happen now is I put this back in the wrong spot. That would be well, that would be too bad. Okay, the rectifier tube is in an unusual place here. Usually the rectifier tube is right next to the output tube, but not in this case. Okay, next one on the hit parade is 12BA6. Okay, I'll get that all set up and we'll do it. Okay, so I foolishly think this will go better if I put that up on the screen there. So you can see 12BA6. It's definitely 12BA6. Let's just get that down right away. Okay, starting 12.6. Yes, 12.6. So the way this is working is I'm reading, you see where it says 12BA6, you just read right across to the right. So there's another line below it. That's another set of settings. So I'm going across B, G, G, G with a dash. B, G, 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 and this doesn't matter. That's what the dash is. Next one is 1, 2, 6, 5, 4. 1, 2, 6, 5, 4. 6, 5, 4, and the next one is 3200. 3200. Just making sure I'm reading across the line. 1 volt bias. Shorts on 3 and 4. 2000 is the expected or the rejection point on this. So bias of 1 volt. Where's the tube? Let's put the tube in. It's at 12. Shorts on 3 and 4. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Back into test position. Bias was 1 volt, wasn't it? Bias 1 volt. Bias. Ooh, what was that big jump on the meter there? Something discharged? 1 volt. So 1 volt, we're on the 10 scale. 1 volt's right there. 1 volt bias. Line check, why not? Ever so slightly high, what does it matter? Nothing at all. Test. We're ready now. The winning result is 2000 and above, and we're on the B scale, 20K. So we're literally on the top numbered scale there. And what did I say? It has to come 2000. So 2000 again. It's just right here. It's no big. Here we go. So it's well above the 2000. Now there is another test listed here. Oh, did I check the current flow on it? 150 milliamps. Slightly low. Another test is a EM test. Now if you look on the chart, the far right you see for 12BA6 you see GM and EM. You see GM with an asterisk. But what the makers of this tube tester are suggesting is the GM test is the test you want to rely on. The EM test is kind of there for interest's sake. I'm not going to do the EM test because that may leave me all messed up. In other words, I got the test result I wanted, so like a good scientist, I'm stopping the experiment now. 12BE6 tests good. 12BE6 not the problem here in this radio. I'm going to stick it back in over here. I'm going to go on to the next one. Unfortunately, like the next one is the last one that can cause all kinds of radio effects. I think it's the detector tube. If I can even get it out of the radio here. Ooh, a lot of dust. Yeah, dust bunny. This is a 12AV6. Got a pile of these guys too. See, this just as an example. See the unusual structure inside there. So if you're looking through a box of random tubes and you got this image in your head, you could find these really quickly in a box of random tubes. You don't have to sit and read the thing. That's if you have a box of random tubes. 12AV6. Okay, 12AV6. Again, it's good I'm going slow because if I don't do this, I'm going to go watch the TV, and it's going to upset me very much. Okay, 12AV6. 12.6. EGGG. So EGG. Oops, let's try that again. EG. Boy, I made a mistake there, didn't I? EGGG. With this one doesn't matter. 12652. 12652. 12652. the last row, 2400. 24000. Okay. 1.4 volt bias. 3.4 just the heaters there show shorts. That's a GM test on the triode. GM test on the triode. Let's plug them in. 12, good. Away you go. Check for shorts. Just 3 and 4. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, go. Blast off. Okay, ready for the test now. Oh no, set the bias. Bias is 12 AV6 bias 1.4. 1.4. Like that. Ready for the test. And the test result should be 750. 750. Well, I think that's way up. We're on the, careful now, Jim, we're on the 3K scale. So we're reading. How does that work? 3? And the result is supposed to be, oh, 750. Okay, that'll work. So 750, yeah, it's going to be, I think, around here. I think I know what I'm doing here. Oh, baby. So low on here. Bias sensitivity, next to nothing. Here we go. Is this a bad tube or not? Pretty sure I don't have anything set wrong. Definitely on the 3K scale. Does you read the 3? 750. Definitely up about here. Time to get some more 12 AV6 tubes in here and do the comparison thing. Here's a look at some of my testing records that I keep for the tubes in my collection, the ones I've tested so far. So in this case, all the tubes here that you see numbered, I've tested, and they are, you know, not so bad I threw them away. Let's put it that way. So these are all good tubes, maybe not great, but they're good tubes. So here's all the 6, here's all the 12s, and there's the 12 BE6. Somewhere I have a bag with 13 12 BE6s in it. So I'm going to go look, not 12 BE6, I want 12 AV6, 12 AV6. I already have the 13 12 BE6s out here. I got to find, oh, they should be right here. They should be right in the bucket beside me. Oh, that's good. Let's take a look. Okay, let's take a look and see. They're right in here. I actually don't have a huge number of 12 volt tubes. There we are, 12 AV6. So I don't mind showing you how I store these. I mean, if you're really into what I'm doing here, you got the same situation. You got a pile of tubes that are building up, and if you've got enough of them, they start becoming a problem just to keep on top of. Pick one, anyone. Pick many mo. Well, that's a nice looking one. I like the way it looks. Let's pull this one out. That's the one from the radio. I'll stick it back in the radio. I can't put it there. put it back in the thing. So basically with tubes, I've discovered there's maybe 3 or 4 different approaches you need to use to, and this would be for a collection of anything, collection of Lego parts or whatever it is. You can't have one uniform approach. It's very inefficient, so you need different storing approaches. for different parts of your collection of whatever it is. Okay, we are set now. I should really check for shorts, but there shouldn't be any because I threw all those tubes out and stuff like that. That tests perfectly fine. Check the bias. Getting to 1.4. Might as well look at the line. Good. Current draw in the tube. 150 milliamps. Right on. Test should be 1286, 750 on what scale? 750 again on the 3K. Yeah, same scale. What are you doing? 750. Up here, lower. Test lower. So, you know, when you only have one tester, then you would just have to accept that. But I have 3 testers plus. I can get the situation so confused. 1286. Short test. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Back. Heat is on. $750. So we got a 3 scale. 750 is definitely up here. Every one of them is coming up low. Bias sensitivity again is just about none. Starts making you wonder. Starts making you wonder. Starts making me wonder. Okay, let me try another one. Go through the short test with it. 3, 4. Test. $750 is up here again. It's coming up to the same spot as the last one. 750 is the reject point. They're all rejectable tubes according to this tube test. They're all testing the same. So I haven't even got to the diodes yet. I gotta bring a different tube tester up here. Here we go. This is starting to feel like a journey into an abyss. Okay, I'm bringing out Old Faithful here. Never wrong, never miss, always reliable. Stark tube tester. Laredo Uranium Mines Limited. I've checked this out with my Geiger counter. There's no radioactivity in it. But the Laredo Uranium Mines would have had this tube tester to test the tube in their Geiger counters. That's why they would have this. So this is my baby tube tester. Having this tube tester is a bit of a dream come true for me, oddly enough. But I would say that because this is the tube tester my high school had in my high school electronics course. And I was very, very fortunate to go to what was probably the best electronics course in a high school, maybe even in North America. The teacher was a ham radio operator, and we spent all of our time doing math. That was it. That electronics, sat at our desk and did math. But there was an electronics lab, and we got in it once for one session. And in that lab was one of these. And I remember walking in. It's a small room, and only like 20 of us students. My high school had about 1,200 students in it, 20 in electronics. And it would have been grade 11 for me, I think. Grade 11? Would have been grade 11, I think. I saw this thing and I was blown away. Look at that! Holy smokes! But we weren't allowed to touch it. Now I own one. Hey, how about that? My teacher was Mr. Borsato. Yes, okay, stop the reminiscing here. So we're going to do a 12AV6. This has a good roll chart. 12AV6. 1, 2, 3 tests in here. 12AV6. So we go with 12. JR. So these two are the heater settings on this machine. Once those are set, you can actually throw the tube in and get it warming up. Then you can make any other changes you like while the tube's in. 3702. 3702 with a 5 out here. Bias of 12. English 58. So this control is what makes the meter read good and bad accurately. If you have this set on English, you're going to set it on 3000 and actually take a reading. So this control actually, well, I don't know. It's be interesting to move this while we're making a measurement on the scale. I don't think I've ever done that. Pick a tube, any tube. How about the original tube? 12AV6. 12AV6. Okay. This guy's sockets are starting to wear out too. What's going on there? There we go. Wow, it's really hanging on to this tube. So this has a shorts test. In a tube tester, the shorts test is more to protect the tube tester than anything else. You don't want to test a shorted tube. Watch the short light. Flashing is welcome. Staying on is not. Flashes are welcome. Good. So this first test, I'm pushing the big P4 red button. So this one gives us two target numbers, 790 at the bottom. 1250 would be a normally good tube. 1250 is going to put it up in this range on the meter. There we go. So this is between the 790 number and the 1250. So this would be defined as an OK tube, but if you really wanted a good one, you should find another. If you want a really good one. Now, good one. And it really depends upon how it's, it's the circuit that it's in. It has a big basis on how the tube will operate, of course. And the tube tester kind of models the operation of the tube when it's in a radio. But it can't absolutely mimic what's going to happen in this radio over here. Okay, check for shorts. Saw the flash. If you don't see a flash during this test, the tube is probably kaput. We push it, look at that, that's higher. So what were those numbers again? 1250. Well, we're not getting up to 1250. 1250 would be up closer to here. That's exactly the same again as the last reading. So these tubes are reading the same, just as they did in the other tube tester. Only this one's a little more reassuring that these are operational tubes. Bearing in mind there's still two more functions in these tubes I haven't tested at all. Once we get one with a good triode. Okay, shorts. There's the flash. That's getting a little better now. Well, I mean, it's relative to the other tubes, it's reading a little bit higher, but again, it's in the same area and it's not getting up to the 12. seems odd, doesn't it? I mean, I've never had a... Can't say, well, all these tubes are worn out. 12. I may have a brand new one in a box, like it's still in its original box somewhere. Maybe I'll try to hunt one down and we'll try that. But it's quite likely. These have all been in radios and they all have mileage. Shorts. Same kind of test. Am I reading the scale wrong? So we're on the 3000 scale. 3000. No. Am I reading this wrong? So 750, rather 790 is a pass. That's at 800. So this is reading like 950. Not that much above 800. It's not that much in the good. I'm going to go off because I need to be distracted. I'm going to go off and hunt down, if I can, a brand new, never used 12AV6. See if I can find one. Okay, let's see what we can find in here. Now, this part of my tube collection I have not tested yet. And although you see all kinds of labels on these boxes, I bought these like this. Goodness knows what's really inside these boxes. You can see people have written on them. And goodness knows if it's a new tube or not. But look at that one. This one looks pretty new. Oh, it's not the right tube though. 12BE6. It's not the right tube, Jim. You're looking for a 12BA. 12AV. I thought I had it. There we are. 12AV right here. Appears to be new. Japan. Lampe électronique. French on it. Distributed by General Electric Toronto, Canada. Now again, this can easily be an old tube. If somebody put the, yeah, look, it's dirty. Somebody put the new tube in the radio and put the old tube in this box. And why would they do that? We're all crazy that way. We just hate throwing stuff out. Is there another one in here? 12. So this didn't really hit the mark here. Just look, 12AU, 12AU, 12BE6, 12AU, 12BA7, 12BA6. Nope, don't see one. Well, for what it's worth, we'll give this guy a try too. It's definitely a 12AV. Yes. Untested. Short. No flash. Oh, there's the flash coming. That's just the tube warming up and starting to conduct. Okay. Here's your chance. Yeah, it's still warming up. Are you going to survive or are you going to go in the garbage? This is your moment of truth. You've made it all the way to 2020. I don't think you're going much further in life. I think you're finished. So, like I said before, I do not like throwing out tubes very much at all. So we're on the 3000 scale. And if we put it on English and do the stupid thing, it says replays. That's for sure. Bias is 12. Yeah, you know what? This is not going to work out. 58. It's all set right. Give them a bias sensitivity. Not going to help them. So this is an example of one that I would pitch. I don't want this in my collection because it's just too weak. You have a big bag of dead tubes. I can't keep myself from hanging on to them. Crazy stuff. Well, what are we going to do here? I have some more tubes to look through. See if we can find some. I think these are all 6s in boxes. I don't see any 12s here at all. No, none of those have been tested. Oh, my last chance. I don't think I'm going to find one in here either. Maybe down here. No. These are semi-organized tubes. See the 6SN7s I have tested, and I have them serialized here. No, not going to happen. Ah. What are we going to do? What are we going to do? We're going to pick one of these. I'm going to stick it in the tester. I'm going to repeat the triode test, and then we're going to check the diodes, and if it seems okay, it's going in. Okay. Well, that's well above 790. I thought none of them were above 790. Yep, it's just spiraling downwards. So these are supposed to be, I was looking for 1250, that's why I'm thinking they're all, yeah, they all test in this range here, which is kind of midway. I think I got a bunch of good ones here actually. Let's stick with this one. We'll switch now to the diode test. 3602 with a 5. 3602 with a 5. 00. P1 diode test. Diodes just have to get above this where it says diodes okay. That's what it says there. Diodes not okay. Okay, so we know this one tested good. They all test actually good. Okay on the triode. I did push P1, didn't I? Hope so. It's low also. So what will happen at this point is I'll go on to the third tube tester, then I'll make a mistake on the tube test. Then I'll come back to this tube tester and realize I'd made a mistake on this one too. And at that point, there's blood coming out of my ears. That's where we're going here. Okay, diode. They're all testing low. All testing low. Maybe they are. Think about all the testing that's going on now in the world over you know what. And I'm painfully aware of how easy it is to make mistakes. And you're watching my video, you are also painfully aware of how easy it is for me to make mistakes. Let's double check something. 36025. 36025. Okay, diode. None of these are testing good. Is there something somebody can see that is out of whack? We're definitely on 12 volts. Can you do a diode on English? I don't think. Oh! You have to do the diodes on English. Mistakes, mistakes, mistakes. The diode good. We're going to go back through them. Oh, were you yelling at me? I make this mistake regularly with this tester. They're all going to test good now. So what we've got here, like average sort of semi-worn out triodes with diodes that are good. This is not going to be the source of any problems with the radio, no matter which one of those I put in. And considering I got no clue now which one was the original, once again I've lost track of that. Diode's okay. I like this one. Made by, it says Tech, I think, T-E-K, never heard of it. Oh, that's a fancy looking tube. I'm not going to spend this one. Look at that. What is that? Need a little bit of better lighting to make this work here. Rin can? Never seen that brand before. Rin. I look with my own eyes here. See if I can. Rin can. R-I-N-C-A-N. Rin can. Never heard of that. It's probably worth $50,000. To a tube collector. Hey, you want a Rin can tube? I got one. And now I don't know which of these is good. Oh my god, what a stupid situation. But that's what happens here, to me. Any one of them is going to work. That's what I concluded before, wasn't it? Didn't I say that? Any one of these are going to work. This one's going to work. Okay, last tube is the output tube, and that's really not much of an issue, I think, for all these problems. 50C5. 50C5. Oops, stop. 50C5. One test. 50 volt filament. JR 27630. 27630. This tube tester. You see the red lines going across there to help you keep your eye on the target. A lot of these testers, they don't have red lines, they just have a window. Good luck keeping your eye on the line. Especially if you're doing a video and talking while you're doing stuff. 27623 023 91. If we care to use English, which I don't want to use, on the 6000 scale, because we're looking at 4725 to 7500 on this tube in this test. Now those numbers are the transconductance or mutual conductance, or whatever word you want to apply to it. Mutual conductance is what they use on the tester. So a tube does not have a specific GM. A tube will exhibit a certain GM under certain conditions. So this thing sets up conditions for the tube, plate, grid, whatever it is that's doing. And then under those conditions from this tester, the number you can expect is this one. That's kind of how they work. You can't talk about these numbers, or you can't talk about the GM of a tube. Shame on you if you do. 50C5. Shorts first. So if there were shorts in here, I think we would know it already from the radio operation. P447. So we're on the 6000. So it's way up in here. So from way up here all the way up right off scale, potentially. Oh my gosh. So my interpretation of this kind of situation where it goes up and comes down like that is that the tube is shot. That's my definition of that one. English set to 91. What does it say in English? The same effect. Oh my gosh, I wasn't quite expecting that. We can't read the current through the heater. Not that I'm suspicious about it, but let's push P4 and wiggle the tube in the socket. Wow, I've never seen one do it that dramatically. What could that be? You know, what goes on in a tube that would slowly relax like that? Unless it's killing my tube tester somehow. So my tube tester is trying to build up a B+. When I push this button, it applies the B+ to the tube. Now the tube is discharging the B+ capacitor in here. Well, why would it do that? Oh, is that weird? That was weird. Kind of went up, went down. Well, I don't think that's proper operation for a tube, and I think I'm on my way to hunting down another 50C5. I don't have a lot of those, if I have any. Let me see. Okay, so that hunt lasted all of about 5 seconds. Because here I've got 1, 2, 3, 4 in here, anyway, of unknown condition. Nice looking new box. Looks like somebody wrote 90 on it. Sometimes people do a test and then write the results. This guy could be new, except the label is worn off or washed off. So this is a, oh no, there it is, 50C5. Okay, this may be brand new. Maybe brand new. So if that's the case, let's think about this. This tube has been hanging around in a box for maybe 40 years, 50 years, 60 years. It's never been operated, never been heated up, just sitting there. There are some components in here which will have are chemically active. They're not. They're degrading slightly. Volatile components and other things in the materials inside this tube. I mean, manufacturers obviously do their best to not have that happen. So that means there could be gas molecules or molecules of something floating around in here that are not really supposed to be in here. So this thing has a way of dealing with them. And it has the getter, which is black, which means it's still got some room to get some more stuff. Now the getter is very inefficient at room temperature. It really works better when it's hot. You need to get it hot. And then it'll start collecting the gas that's in the tube. The problem with the gas in the tube is if you start the electron flow in here, if you put, heat up the heater and the cathode, and then put voltage on the plate, you'll have electrons with some energy in them moving through the gas that's in here. They'll strike gas molecules and ionize them. They ionize them positive. Guess where they're heading? They're heading straight for the grid. Maybe the cathode, but the grid. The grid is the most negative thing in the tube. And that's bad. Bad. It causes current in the grid, but also the gas can contaminate the cathode and ruin the tube. So now, how serious or important is all this I'm talking about? I don't know. But I recently read, and certainly in the case of very old tubes, this is not a very old tube, but tubes from the 20s, real antique tubes, you should assume there's gas in them, and the step you need to take is to heat them up with no voltage. So in this tester, anybody knows the fuse light come on briefly? In this tester, unless you push the test button, there's no high voltages placed on the tube. So what I'm going to do is this is craziness, I'm going to let this just heat up here for 15-20 minutes, and on the assumption that much of this gas, if it exists, will be getted getted by the getter. Is any of this true? I don't know, but it's just a new sensitivity for me about older tubes. I don't care too much about this one, but I think in the case of a real old tube, you've got a piece of history in your hand. You wreck it, it's gone. There's only so many of those tubes around, and if someday somebody starts making them again, I don't know why anybody ever would, well, those just wouldn't be real McCoys. So for all of us doing this kind of work, we have a little bit of a dutiful approach to vacuum tubes because of the limited supply. Not very limited today, let's say, but only for some tubes. Many tubes. There's lots. I've got them. Okay, so I'm going to let that just heat up there, and the theory that it's doing something useful. Okay, a lot of time has gone by, about maybe 45 minutes or so. So we'll start the test on this guy. He's all set up, 50 C5. Just double checking things quickly. No problem. Shorts. Oh! Yeah, I could have done that half an hour ago, 45 minutes ago. Well, that's a dud. Can't go any further with that. Well, son of a gun. Yes, let's get them out of there. It'll be very hot. Very, very, very hot. This tube. So this is going to listen to the sound now. That's it, going right in the garbage. Can't afford to have a tube with a short in it. And I thought it was going to be new. Oh, Japan. No wonder. Okay, let's try another. I got more. I got a couple more anyway. There's another one here. You know, I had this feeling in the back of my mind that once I start this tube testing, 5 tubes, I'll spend my entire day doing these. I think that's what's going to happen. Is this really a 50C5? 50C5, yes it is. Does it look used? Yes it does. In you go. Well, I don't think it's heating. Oh yeah, it's heating already. Any shorts in this tube? Flashes are fine. No shorts. So now we're going to leave this thing going here for 30 minutes after my gas speech. Now I did a gas speech. Now I'm stuck living up to what I said. Talking about gas. Now that last tube, the other 50C5 I tested where the meter went way up and then just came back like that. That might be a strong indication that that tube is gassy. There is a gas test that can be performed with this tube tester. I'm not familiar with it. Done it a couple of times, but can't do it off the top of my head. It's an odd thing. Okay, I'm going to let this guy sit for a little while, and then we'll hit him with the test. Okay, back from watching the TV. Shame on me. Shorts. Shorts in a knot. No, they aren't. Good. Success. Okay. 50C5. So 4725 is the lowest. So 47 is going to be up around here. Pretty high on the scale here. And off scale it's 7500 if it's really good. Okay, so that passes. Now I'm going to get that other one, the one that was gassy. That's the one that's... Okay, hold on. That would have to be this one, the only other. Wasn't gassy? Yeah, it was gassy, but it had shorts. No, what am I thinking of? Help me somebody. Yeah. Yep, I'm too confused to be doing this today. So we got a good one. We got a good one in everything over here now, don't we? I think we do. I think we have a good tube for everybody. But that's too hot to handle, so I'm going to go away again, let it cool off. Okay, wait a minute. I just left for a minute here, but I think this is the original one with the bizarre behavior. Let's do that one again. If I see that dropping needle thing, and I think it is gas, I'm going to leave this tube heating here while I go and have my lunch and whatnot, and then we'll come back and see if the effect has changed. If by some chance, if it is gassy, the gas has been consumed into the getter. That's my plan. Doesn't that sound exciting? Okay, now this one's definitely not shorted. No. Here we go. You see the drop? Now, I'm just going to leave this in here for like an hour or two. I have no idea. I mean, you got to think about this a little bit. If there's gas molecules floating around in there, they actually don't care about any charges or any voltage because the molecules are neutral. They're not charged. So they will just flow out into, like any gas would, they'll just fill it. Fill the glass. Some of it bumping up against the getter, which is up on the top here. So there's nothing like the getter's not sucking in the gas, not really. It's just whatever molecules should brush up close enough to the getter chemicals. Chemistry happens, they get locked there. The pressure goes down a little bit, I guess, in terms of that particular molecule that's floating around. I guess what I'm trying to say is it might take a long time, just based on chance, that molecules in here will end up bumping into the getter. And I think what I read was below a certain temperature, like at room temperature, the getter really doesn't get anything. So, okay, let's leave it. And I'm going to go eat some lunch here. Okay, lots of time has gone by now. Maybe an hour has gone by. Before I do this, here's a piece of interesting information. 3M makes face masks in the United States. It makes them using Canadian pulp and paper. Hey, how do you like that? Okay, now let's just... Oh, for crying out loud, I put the... What did I throw out? Wait a second. How's this work? I threw out a good... What did I throw out? I threw this out. Let's check that again. Can't test the tube if it has a short. Good one. Yeah, I'm definitely going down the river of confusion. And I'm paddling along like crazy. There's a short showing up here. I don't know if it's really visible here. Let's see. You can kind of see it now. There. But that's in a different spot. Oh, I could have missed that. Oh! Okay. Two with shorts. Ooh, what happened there? Did you see that? I don't know. Okay, two here. Yow, it's hot. Woo! Hot diggity dog. And unless I've really gotten into massive confusion, this one's good. Fuse light comes on because of the heavy heater draw at first. Flashes are good. Is there some way I can get that to come on? Nope, can't get it to come on. That's a winner. Don't do any more, or it won't be a winner eventually. So much for my gas experiment. I'll have to save that for another time. I really intend to do gas testing type stuff with the old tubes, not so much with these. Okay, is that really hot? No. The fact that there's shorts, or appears to be shorts, maybe there's a short, that could explain the hum in the radio a little bit. Could explain the garbled voice. Maybe. Now what to do with all these tubes? In they go. Okay. So what I'm going to do is I'm going to get this radio ready to go here with a replaced tube in it and see if a miracle has occurred. Okay, I think it's time to test this radio and see if anything positive came out of all that. I'd be a little bit surprised, in fact. Here we go. Okay, just a little bit of a glow there. It's a nice, like a gigantic clock too on this, which is a really nice feature. Gigantic radioactive clock. There it comes. Always a little impatient with these guys here. And we're going to have to pick up a signal to listen for the garble. I wouldn't be surprised if it's a little different. Okay, we'll boost it with this. Not this. We'll boost it with my crazy antenna thing here. Antenna thingy. Just get that out of the way. Clean this up nice and close. So I may have this hooked up to the signal generator, not the antenna. That sound you probably heard was me banging the microphone. Antenna.
People's lives, makes it all worthwhile, and gives other people
Wow.
look like, and that they have options, and they should be looking at all the options that they have and choosing the right one for them.
It's a great way to end it, my friend, and we'll do exactly that. Keeping our distance, but staying close. That's what they say. We can beat this together if we stay apart. So we'll continue doing that, and we'll reconvene next week. And I know you have more stories from me. In the meantime, you want to reach out to Yvonne and her crew. Do so. This may be a very important time to do it. If you've been thinking about it, act on it. Chipradio.ca, and we'll catch you next weekend right here, Retirement Life Show on Global News Radio.
The preceding was a paid commercial program. Unless otherwise identified, the guests on the program are employees of or otherwise represent the advertiser. The opinions
Oh, is that so?
necessarily reflect the views and policies of Global News Radio 640 Toronto.
Sounds like that was an infomercial. Infomercial they were admitting to there. So that was 640. Sportsnet, this is 590. Usually this is stronger. Let's try it on its own now. I'll take this away. what you're listening to, right there. This guy. This guy, he looks like he's got a transformer in it because he's so big. No, I don't think so. He's not heavy enough. There's not enough in there. So, maybe it even says right on it what it is. And what is this powering that I needed in here? Goodness knows what it's powering. I don't know. Hello, can you hear me still? Yeah, I think you can. So yes, I've been hunting these guys down, and I was pretty suspicious about this one. The thing about this is, this guy makes noise at that spot on the band. The other guys make noise at other spots on the band. You tune one in, and you can convince yourself 6 or 7 of these things aren't making the noise. Well, they aren't at that spot. But if you tuned a little differently, maybe one of those ones will show up now. And since I have got a plethora of these things around, but I try to keep to the transformer ones, the ones, you know, that are heavy. Yeah, you know, this one fooled me. I'll have to dig out a transformer one. It's pretty quiet with this out of the picture, isn't it? Wow, this is the bad actor here. Now, I had it plugged in right under here, like 3 inches under here, as I want it to perform exactly this. Okay, let's put it back in. Gotta fix that part too. Here we go. Going back in. Well, that's the bugger. Well, that's one of them anyway. Great. Okay, so that worked out really well. I'm going to guess it was the output tube and a short in it, in the output tube, that was responsible for the garbled sound, which I wouldn't have guessed at. Good. What's next? Okay, so now we're ready to do a proper alignment on this, and it's heading back in the cabinet already, I think. It's really fantastic. Okay. Well, thanks a lot for watching. It's a bit of a choppy video, perhaps. But hey, we're all living choppy lives these days, aren't we? Canadian pulp. See ya.